Hi everyone, I want to welcome you to another section. Thank you for subscribing to this channel, and this is another series of video I want to make. It's about organic chemistry, and I'll be using this material to explain different concepts that has to do with organic chemistry, and I hope that this this tutoring will be very helpful for every student that is taking a course related to basic organic chemistry. So also I also want to say that this material is not mine, so I'm using a compiled notes by a student from University of Obafemi Awolowo University in Nigeria. But I believe the note is structured and it's very good and very useful. That's why I'll be using it in explaining different things that we'll talk about in this inorganic chemistry. So, and the first thing we'll be looking at, which is like an introduction for subsequent things we are still going to talk about, is covalent bond. So, but let me just talk a bit about organic compounds. Organic compounds are compounds of carbon. They are mostly compounds of carbons, hydrogen and oxygen. Sometimes they also contain nitrogen, sulfur, phosphorus, and mostly they are found in living system. Yes, they are compound. They are usually organic compounds are found in living system. So that is like a simple explanation I can give related to what organic compounds are. Some of them, example of that which we might have heard about, is alkanes, alkynes, which are hydrocarbons. They are organic compounds. We have different classes of these compounds. So, but the first thing we'll be looking at under this wide field or subject is covalent bond, because covalent bond is the prominent bond type of bond that is present in organic compounds. So most organic compound has covalent bonds, so we have to understand covalent bonds and what it implies. But that doesn't say that we can have other type of bonds, but the prominent, like I said, type of bonds in organic compound is the covalent bond. So the first thing is to talk about how covalent bond is represented. So in most cases, a covalent bond is represented by a line, like a dash line like this, that represents a covalent bond, and each covalent bond contains 2 electrons. Yes, each line like this, dash like this, contains a pair of electrons. So, and that's why you have 2 dots here. So you can also represent covalent bond with these 2 electron dots. So you can see that a proton, hydrogen, has 1 electron, and another hydrogen atom with 1 electron combined together, and they form they shared their electron to form a bond. And that's typical of covalent bond, in the sense that electrons are shared between 2 atoms in order to form the bond. So these 2 dots is represented by a line, a dash line here. So this dash line, these 2 dots, the 2 of them represent a covalent bond. And like I said, what is typical of covalent bond is sharing of electrons between 2 or more atoms, in order to attain a stable state, which in most cases we refer to as octet state, so, or duplex state in some cases. So we also have other types of bond, which is electrophilic bond, but electrophilic bond is more of transferring electron from one atom, in between the transfer of electron between two atoms. So you can imagine that sodium atom that has an extra electron transfer its electron to chlorine. So in that case, when sodium transfer its electron, it means it loses electron, it becomes positively charged. It means that it has losing one electron. By the loss of one electron by sodium makes it to have extra positive charge, and that means that's why it becomes positively charged. And chlorine gains one electron, and that means it has chlorine now get to a state where it has more negative charge than positive charge, and then it carries a negative electron. But in this state, sodium is stable because it has a complete number of electrons in its outermost shell. Yes, and chlorine also in this state of being negatively charged is also stable, having a complete electron, an octet in its outermost shell. So that's all. So but the reason for interaction in these states for Na plus and Cl minus is attraction force. When you have a positively charged atom and a negatively charged system, they can always attract each other. It's just like law of all these electrostatic charges, so something like that. So we have Na plus attracting Cl minus, and then they form a bond. So it is wrong to represent the bond between sodium and chlorine as a dash. Yes, so in most, you don't represent an electrophilic bond by a dash, unlike what you would do when it has to do with a covalent bond. A covalent bond can be represented with a dash because the two atoms involved are sharing electron. But to do that for an electrophilic bonding which involve charge system, it will be very wrong. So in the case of electrophilic, sodium has extra electron, and then it transfers it to chlorine. Chlorine accepts this electron and becomes a negatively charged ion. So and that's how electrophilic bond works, and the correct representation of electrophilic bond is what is shown here, where you have Na plus Cl minus. That's, you don't use a dash to represent an electrophilic bond. Now another thing also is that there are some cases whereby you could have a compound that is both that is having these two property. That has a bond, that you can have a compound that has a bond that possess these two character. Yes, so a bond can have these two character. It can have covalent character, at the same time have electrophilic character, but in most cases one is more prominent than the other. For example, HCl. So this is hydrogen. Hydrogen has one unpaired electron. Chlorine also in this state has one unpaired electron. So the two of them could share this one like each of their one electron to form a bond, and that makes a covalent bond. Yes, so that is possible. In this case, you can have H donating one electron, Cl donating one electron, and they interact and they form a stable state. That's why you have an HCl, and because they are sharing their electron, then it becomes a covalent bond. But in the same way, hydrogen can also lose its single electron to chlorine. When hydrogen atom loses its single electron, it becomes positively charged, and chlorine becomes negatively charged because chlorine accepts. So it means I could have H plus and I could have Cl minus, and these are two oppositely charged entities. They can they can bind together, and then we can still assume that this is an electrophilic bond. So the bond between hydrogen and chlorine has both electrophilic character and also covalent character, but in a way you could much preference is given to covalency for HCl than ionic. But there are situations where HCl behaves ionic, like you have in acids. Yes, that's that. You have the ionic character like taking much preference, and there are cases whereby the covalent character also take much preference. So, but there are some examples of compound whereby this is very distinct in a way. So like I said earlier, you represent covalent bond using either electron dots. So you can use dots to represent what's it called, you can use dots to represent in summary, you can use dots to represent covalent bond, and you can use a dash to represent, but you can't do that for electrophilic bond. Okay, another important thing to talk about in this aspect of chemistry is talk about Lewis structure. So Lewis structure is a structural entity of a particular compound. I want to describe it that way. So it shows us the structure of a compound, showing the bondings and at the same time the non-bonding electrons. So a Lewis structure shows both the bonding electron and the non-bonding electrons. So the bonding electrons are indicated with a dash, which I have said that means they are covalent, and the non-bonding electrons are represented with electron dots. So the structure of a compound that contains both the bond, that shows both the bonding electrons and the non-bonding electrons, is what we refer to as the Lewis structure. And you will mostly see this with organic compound. Yes, you will most of the time see this. You will see different organic compound having dash and dots. Yes, containing dots showing the unbonded electron, dash showing the bonding electron. So you will always see that in organic in this topic that we are in organic chemistry. You will see that a lot. So one of the things we are going to talk about is how to represent organic compounds or compounds generally using Lewis structure. But to round it up, so that in the next video I could talk broadly about how to draw Lewis structure, so I would want to stop here. So the summary of this introductory aspect is to know that organic compounds are compounds of carbons. Like I said earlier, they are found in living system, and one of their peculiarity is the presence of covalent bond, and that's why we had to talk about covalent bond and how to represent covalent bond in this situation. And at the same time, I also talked about Lewis structure as a structural entity, as a structural representation of a molecule that shows the bonded electron and the non-bonded electron. So you could look at this as example. This is methanol, and the Lewis structure, you can see this. It shows the bonding electron and the non-bonding electron. This is for methanol. This is for ammonia. This is for water. So I'm going to discuss how to go about this, how to draw Lewis structure, Lewis structure in the next video. Thank you.